Hello, hello. Couple minutes late, but not too bad. My Elgato capture card decided not to work for some reason, and I opened up the program and I went, "Oh no!" But a restart worked, so fingers crossed. We don't run into any other weird oddity things today. It was a long weekend for me. And I suspect for many folks in the US, I think other countries have holiday or time off yesterday as well. But I don't know. I don't. It's definitely not a like worldwide thing as far as I am aware. But I got a little sun. We were doing a lot of planting and digging, and I built a couple planters for the parents-in-law so they can plant some tomatoes. Caprese. Caprese is so good. Anyways, getting older. I feel that. All that manual labor. I'm not. It's catches up to me faster than it used to. But anyways, we are looking at WGPU again today, specifically in the WebGPU and trying to get a shader working with some WGPU code and have it compile into WASM, which can run and hit the WebGPU API that should be in the version of Chrome that we're using. I don't know if it's. I do eventually want to. The shtick here is that this background is what we're creating. We are, rather than having these like hexagons, we want to do voronoi and have them slowly move, not in like a way that's distracting, but subtle. So that's what we're working towards. We'll work on it some today. We'll see how far we get, and this either will be something that I finished up off stream or we continue next time. Let's see. I noticed that my let me flip over here. I noticed that my window snapping is not seeming to work. It's not lining up. We're streaming off of Windows, and I use a program called PowerToys that's been around for a while, and it's a program that's actually put up by Microsoft, like officially by Microsoft, and it's kind of as it feels like a lab type of program where they like can experiment and like try things out a little bit and see how they land and see how they work. And some of these things that there are or used to be in here have slowly made themselves into like official windows. This fancy zone's super nice. We want this one. There we go. There we go. Now we can get some nice snapping in there. So where are we gonna put this? It's not specifically going into stream overlay, but I might. It's gonna go like it's part of the stream, but I don't think it's specifically in an overlay that we're gonna put this. But honestly, it might be fine in here still. Granted, it might be a little bit awkward, but it might make sense to put in here. You know, I just realized I don't know if the chat is still working. Oh, that would be sad. Action cues. Completed count. Maybe. I got the chats working. Okay, slight distraction. So I thought I had this working last time. There was like 2 or 3 servers that I normally have running that I hadn't like set up or switched over from the old computer and set up yet. We did get a drop when it first started, so something is actually connecting. It should be that if we send this command, we should see nothing at all. I am seeing the command. It's coming in. Seeing it as a command. Is it enabled? Probably move it over. Some of these are, so I've got a chat bot section in here that I imported. All of these you can see still are actually targeting Twitch. But like I imported these, so these weren't ever ones that I actually had set up, I don't believe. Broadcast started, broadcast ended. I bet you that's it. No. That should be fine. Well, we might just I feel like this command had something in it. And I feel like that just didn't come over for some reason. I might have to like reset that command up. Are we even getting any chat events? Because that would be kind of annoying too. So it's coming in through the queue. So we're seeing the chat event. Message. Let's look at the console here real quick. Hey Chris, good to see you. Thanks for stopping by. I am taking a brief aside because we have switched over to the new computer. Was it last week? 2 weeks ago. Time is compressing. And our chat thing has never worked since we switched over, and I probably missed something, but don't know what it is. Enter, send chat. Do we get a log? Yeah, it's just straight up not coming through. Well, I don't think I'm gonna bother with it today. I kind of want to get cranking on this WGPU stuff, so shrug. Which is unfortunate. I mean, I can do. Wait, I got. What does that button do? There we go. That's what I meant to do. There we go. That's the command that I want to run. There should be a command that you can run, ! Drop, which actually triggers that. Sad it's not working though. Next time. We will get it next time. I am very set on getting it working next time. But, well, let's look at WGPU stuff. I think... Do I put it in this folder? I mean, I guess. So what do I call it? What should I call it? It's gonna be its own like little project, but I might do other little things like this as well. So maybe we say extra sources. What the heck do I call this? So the idea here is there's this background here, and on a couple other places. We are going to try to write and or take existing examples and create a voronoi with a shader code, put it in, write it with, or take that shader in with WGPU, create a WASM file which can run in the browser and hits the WGPU API to where we can see shadery things, and we're going to put that as our background. Just because it's kind of a cool thing like that we can like come back to. The drop, those 3D models that came down, we did those in Blender on a previous stream and exported those out of Blender through a .gltf file and imported them into React 3 Fiber. So it's kind of cool to like build up on the stuff that we've been like continue to work on the stream over weeks, months, and years, I guess, at this point. Definitely over it's definitely over a year now, right? We're coming up on 2 years? No. I'm gonna have to look at that. Wow. Anyways, lots of videos. Hit that subscribe button wherever it is that I never remember where it is, and go ahead and watch the back catalog. I will also start getting videos out of shorter compressed versions of what we got in that back catalog, especially around Tori stuff. I've got a bunch of things that I want to do around that. Anyways, focus up. We want to we've got a repo called Stream Overlay where we have the Stream Overlay that seems to not be working at the moment. Not because the Stream Overlay is necessarily broken, but because I don't think I have the last connection in here set up. I think we're just gonna say like additional sources, and we're just gonna dump everything in there. And we're gonna say for voronoi background. That was supposed to be a folder. Folder. Or music pause? Music paused. All right. So we were looking at, we were sort of understanding how things came together, looking at examples and planning out how we should approach this. And in the WGPU repository, did I sign into GitHub last time? Guess not. I don't actually use this browser for like daily use. This is a streaming only profile for PII reasons. There's an examples folder in here, and we're gonna take this boys screenshot pending that really pending. got an example here. Private live demos. Voids. We're gonna take this example, tweak it. It imports 2 shaders, I believe. We're gonna take that, and we are going to sort of combine it with something in the vein of this. We might just, I mean, they've specifically stated here that it's MIT. We might copy and paste it just to get going. They've got a note here that this is like the regular voronoi, and like that's really straightforward. And we have some indication of like eye time where we could slow it down a little bit and whatnot. Where does that show up actually? Eye time, smooth step. So I believe main image is the thing that actually does the render. It's doing a combination of vec1 or vec2, excuse me, vec3. So vec2 is the hash, which I don't know what that's actually doing. And then vec3 is the voronoi. And then borders. So voronoi, vec3 takes vec2 and x. Where's eye time coming? Oh, shader inputs. Ha. Shader playback time. I haven't used this enough to actually like know where the inputs are, to be honest. Filed. I don't know. But either way, this is straightforward enough that I could copy and paste some of it. We can make sure things are working, get it set up, and then we can make our own version of this. This as a graphical thing is pretty well established, and the math is pretty well established, so it's something that we could just like read some articles and figure it out ourselves likely. But this will get us going quick, and figuring that out isn't something that we want to focus on the stream. So this is going to give us the basis for like what we're trying to accomplish, and rip out some of those pieces and replace the shader with the other one. That's what we're going to try to shoot for on the stream and see where we get. So in this examples folder, we got a couple files. I guess I can mostly just take this. So I'm going to go ahead and copy that, and we're going to add a main.rs, and we'll see how Rust Analyzer picks this up. Failed to discover workspace. I think what I'm going to do is make a cargo workspace, or in the root make a cargo.toml that sets a workspace and points to this folder down here, so that Rust Analyzer ends up picking it up nicely. We could also open up VS Code in this specific folder here, where the main.rs is. That would also work as far as Rust Analyzer is concerned. But I think just setting up a root workspace is going to scale a little bit better for the moment, or for the I'm expecting for the future, because I think we will continue doing Rust stuff. At least that's the plan. So creates a new cargo package. I thought there was a way to set up a simple workspace just from cargo. Clean, I don't see it. Cargo root workspace. without a package. This is called a virtual manifest. This is typically used when there's a primary package. Yep. So I think this is what we're going for. And we can do cargo.toml. This members is going to be, we don't actually have a cargo.toml there yet. So we're going to say, cargo init dash h. So directory in here, bin registry. Config name. Use a library. There's not a path. Haha, it's one of the argument. It's one of the main arguments. Okay. So additional sources, voronoi, background. So now we have a did I spell it wrong first time? Oh, I just spelled it wrong now. Okay. Let's move this. I don't need that main.rs there. I do need an extra O there. So then I can do name, and we can do name, and hopefully Rust Analyzer starts to pick this up. We can also do cargo check from the root, and that will let us know it cannot. Oh, what? Did I put a 0 in there? Huh. I did it again. Oh, not 0. Cargo check is telling us that it is trying to load a manifest. I did it in the root too. At least that was consistent. Failed to read stream overlay. So I need to do additional sources / that. I don't remember. I don't remember if I need the actual thing in there. No target specified in the manifest. Okay, so we need in here a interesting that it didn't add in a main reference. I don't remember what it is offhand. So every cargo.toml can have these target tables. So like we are looking at a example, which if we look at the main WGPU, let's go ahead and grab some of this, pull some of this over actually. We are going to grab all of this. These are newer. I don't remember what it's called. There's a specific name for this, but this basically saying take this information from the root. And do we need a specific? So it just doesn't not like a. Huh. I guess the toml parser doesn't like that. That's interesting. Yeah, sure. Addition is fine. We'll take that addition out. Do this and this. Let's do save. That should be save without formatting, I believe. Gonna exclude auto tests docs. So here you can see they've got a lib and then an example. So when we from this or for this package to run the examples or to run these things, they are examples, so you would use the dash dash example flag. But this is going to be like our main. See, but this is going to be our main, so I want to we might end up needing to set up some of this. I'm not going to make it as an example. We're going to set this up as our main. Is there anything else that we actually need in here? Some of this stuff we might end up actually needing, but I think I'm going to leave it out and let us naturally run into the issue. So there's some assertions and stuff. So we are specifically WGPU core. I'm thinking we're going to want something like this because we are doing WASM. We're not going to bother with direct 3D right now. Render doc. Windows dependencies. So this all looks like DirectX. Windows RS is a crate that has a bunch of Windows dependencies in there. I don't know why we would need or what we need that for. And if we would look at the main.rs that we copied over, make that a little bit bigger. I'm not going to bother with this test. We have a framework here. So we're going to have to we're going to have to worry about this. So I think when we were initially looking at this, I think I want to say that we were expecting this file here to contain most of what we need. But I don't think that's actually the situation here. So we were in the examples folder. Okay, so it's doing framework. And it's pulling in WinIt. If WASM 32. So like we'll need these. I suspect a bunch of this we're not going to need. So like window and WinIt. This is all for DirectX, which we don't necessarily care about. We need a canvas, and then we need the WASM bindgen stuff. So that's the bits that we're going to start to care about here. So we might need to grab this and like chop it up a bunch. Is it pulling anything else that we need to worry about is the question. No, it doesn't appear to be. So the WGPU reference is there. I guess they're doing they're not doing AUs, they're doing a lot of like direct imports. Okay, so we might need to grab a couple pieces from here before we can actually get it to run, but I think we're gonna get it like mostly set up and working and just start running it and use the compiler to our advantage. The compiler, if you haven't used Rust before, the compiler in Rust is very helpful. In some ways, I feel like I could not write Rust without it. I definitely appreciate what they've done with the compiler with in terms of usability within Rust. Okay, so Rust Analyzer, can we just restart? You've failed to discover workspace. Are we still getting okay? Caused no target specified in. So we neither need a lib, a main, or a yeah. So we need the target. I don't remember what that is. We're just going to kind of cheat and look at one of these. So just assume cargo run. I thought that was like is it just lib? No. Alright, we're gonna have to look it up. Cargo main. Okay. Yeah, yeah, no, we don't need anything. Why is it complaining? Failed to load manifests. For a workspace member that caused by failed to parse manifest. No target specified in the manifest. Do we though? I don't think we. Okay, kitty. Come on. She likes to look at my green screen. And I see that just moving around in my. I see that moving around in the peripherals, and it just really drives me wild. Hey, happy to see you stop by. We are working on using WGPU to create in combination with a shader and some Rust code, create a WASM file that runs in the browser and hits the WebGPU endpoint, the API. The WebGPU API is sort of the newer or the next version of what WebGL was handling. So if you've seen or used libraries like 3JS or React 3 Fiber, that's like how you did 3D. Yeah, I mean, it still is. It's still going to be in a big way, but WGPU is like the updated and the newer spec and standard. Cat. I got 2 cats. Wanna say hi? Oh. Say meow. Nope, she's gone shy today. See your tail. She'll sometimes talk on stream. Social cats. Okay, so why is this not doing the check? No target specified in the manifest. But so it defaults to bin to make a binary. We would pass lib instead. Yeah, like this is all I have, and like. Okay. Do I have I don't have a source. That's probably what it is. src/main.rs. Cargo check. Do we get a compile? There we go. Okay. Yeah, I forgot to put the source directory in there. What are we building today? We had a string, a couple of people join. I explained myself a couple times, but not a problem. We are looking at using WGPU, which is a Rust crate, in combination with some shaders to create and compile a WASM file that you can run in the browser that's hitting the WGPU API, which is the newer updated spec. I don't know if it's necessarily replacing, but it's like it's accomplishing the same, like not feature set, but it's filling the same role as what WebGL used to. There you go. There you go. Thank you. I gotta get this stupid chat thing working again. I need a exclamation mark projects command that'll help you all out, so I don't feel like I have to like try to explain myself every time. And granted, back to back explanations, I'm starting to get it down. Okay, so this is running. It is now compiling. I need these in the root because I am referencing these. I don't remember if did I put them in the workspace? I think I put them in the workspace. We'll find out. This workspace.package.version was not defined. Okay. So there's new workspace inheritance. That's the word I was looking for before, I think. There's a new-ish feature. I think it released the end of last year, where you can specify things in the root, and you can in the within the workspace, those crates within the workspace, they're able to just reference those values directly. So like we can say edition 2021 in the root and have every crate within that repository or within that workspace use that same edition. So it helps with some of those values that you might just want to have set in one spot. So like single source of truth situation. Let's just call this root. I've got a package on here that like formats TOML files. I use it, the less I'm thrilled with it. Okay, failed to parse manifest. Now I want a virtual workspace. Workspaces. We want to set up a virtual workspace that has members. So the root package do I need a target? So you can create a virtual workspace without a package section. But then I guess we can't use workspace inheritance. Just gonna do this. I think it's a double bracket. Oh, stop reformatting me. For me. Invalid type. Expected error. So just one lib. So I want to be able to just run like cargo check Cannot find library root. Rename file to. Okay, you know what? We're gonna not care about workspace inheritance. We're gonna deal with it later. I just don't feel like dealing with it right now. Bam. Good to go. The goal here specifically is being able to run cargo check in the root. There we go. And then that way Rust Analyzer should not complain. Let's just do a reload window. So now it should discover the cargo.toml. And there we go, Rust Analyzer. So Rust Analyzer should now start working, which is quite important. We can get rid of this one because that was the one that I misspelled. And now let's swap these out. There we go. So now this is our new main RS. Rust Analyzer should pick that up, and we're going to start getting failures basically because we don't have this framework.rs. I can't remember if I need I think you can do just mod. Like if I made a file here called framework.rs, I think I can just do mod framework. Yeah, looks like it. Okay. No code actions available. Interesting. Okay, let's grab a couple dependencies. We want to look at, so the idea, I think I forgot to mention this. The idea is that we're going to take this shader, at least as a way to make sure that we have everything set up and it's working. We're going to get this shader into basically our WASM file. And then once we get that set up, a version of voronoi is what this background will eventually become. And considering the random things that we've run into so far, I think we're basically going to get as far as like copying and pasting this in there. And then I suspect next stream is going to be what is a shader and how do we do the math and things. Okay, dependencies. Dev dependencies. They don't actually have any WGPU in here. Probably because it's okay, create import sort of situation. That's the downside of having examples in. The downside of having examples in one of these things, it's like within the main repo. Because I feel like I don't know. I mean, I don't see that there's a better way to do it. But the downside is that you don't necessarily need to like set up or import your, the use dependency in the same way. So like, if I want to use or have this make use of this example, I end up having to like sort of manually transpile some of it to get it to work. Okay, so standards should come in. WGPU should start coming in. This nano rand, I'm not sure. We can see Rust Analyzer is doing its thing down here. We can bump it up just a little bit here. So it should start like telling us if some of these things aren't actually imported. The mod framework is throwing an error here. And okay, and nanorandas. Do we need that? Range. Where does that show up? Oop. So this is all particle stuff. We might not actually need nanorand. So we're gonna end up ripping out a bunch of this. How about we just put it in here? We'll get stuff working. Kind of one piece at a time. Yeah, I think that's the way to go. We are gonna like copy and paste the main.rs, pretty much copy and paste this framework.rs. Theoretically, what we have will end up working on DirectX as well as like web as a target. This is something that we're looking for specifically, but that's going to be fine for the moment, just so we know that we have things like set up correctly, and then we can start tearing stuff out. We'll do it in steps. Because if I mess anything up in all of the setup and like tying things together, and I try to rip things out at the same time, it's going to be hard to determine if I made a mistake in ripping parts out, or if I made a mistake in like how things are connected and set up. So we have this include string. It is looking for these files. We don't have those yet. Let's go ahead and grab those. These, at least one of those, we're gonna need at least one of these. I'm not sure if we're gonna actually need both of them or not. Let's get rid of, got a bunch of random, like, not gonna use any of this view press, cache, next. What am I using with the, Vite, we're on Vite, okay. Let me just ignore this target folder. Oop, I deleted it. That's annoying. Discard changes, restore. Right now the target folder and a few other files in here are things that we can ignore, but I'm not. And that ends up meaning that we've got 1000 file changes, which isn't the case and isn't useful to keep around. We're never going to use NYC. No modules is fine. TS build, npm. Sure. Rust. Yeah, that's fine. I think that's fine for now. There we go. So we now only have 6 files. So let's get these the compute WGSL and draw WGSL. Those stand for, if I remember, there's GLSL and WGSL. Is it web graphics shader language? GLSL is, let's stop guessing. GLSL. Where is it? OpenGL? OpenGL's shading language. What? probably why I wasn't remembering it. Did we look that up? That feels... I guess it's OpenGL shading language. OpenGL stands for Graphics Language and Producer. Right? Pretty sure. And then there's WGSL, which is the WebGPU shading language. But we can write in WGSL, which I think is going to translate a little bit better to HLSL, I believe it is. Very similar, but the reason this matters is because I can use HLSL in OBS, which is the streaming program that I use. So we could do shaders that are both something that I can export and put in a browser source as a background, but also a shader that can like change the camera. So you could have a command where you like change what the camera looks like. Okay, let's grab these couple files and get things set up here. Draw.wgsl. It might be nice to have a language service for that, but I'm not gonna care about it too much. WGSL you can use that in Shader Toy now. Nice. Which makes sense because Shader Toy is primarily a website. So it makes sense that they're looking to support the newest API. I honestly don't know how different they are, but I think WGPU works with both as well. And I believe it is what is it? Naga? GFX-RX is the, you might note, the organization that does WGPU. WGPU uses Naga as a like create dependency, and it does. We can write in Rust with Naga and export to HLSL and GLSL. Okay. But I imagine the things that we're going to be doing, okay, is probably going to be sufficiently okay. So I think when we really like start getting into shader stuff, this is the thing that we're going to try. TBD on when we actually do that on stream. But we can use this library and write with this, and we get multiple exports and potential use cases for it. I am actually a little bit curious how this translates into WGPU itself, but we will look at that when it makes sense to look at that. All right, let's throw in the compute. So those should start being okay. WGSL, yep. Failed to resolve use of undeclared crates. So nanorand looks like a dependency that we need. That's curious. Why is it dev dependency? Feels kind of odd. We'll go with it. We'll go with it. Oh. nanorand, is that also in this? Because it's workspace is true. Yeah. Nanorand is it in this? Is it in this workspace? And that's why they don't actually, whoop, wrong one. Cargo Tamil. Run WASM. They must pull it in somewhere. Nanorand, yeah. Workspace dependencies, there you go, okay. I think we are gonna do what you're suggesting, Tab. And do that. Default feature is false, okay. Let's go back to here. That should give us this. I believe that's where ByteMuck comes from. That seems to be the last of the actual notes about errors here. So we're going to go ahead and let that do its thing for a minute, and come over to this. Get this working. We don't care about the tests, so I'm going to just delete the tests. I don't technically care about winit right now, but I think I'm going to. What? I could have sworn that code actions worked where you could add winit, but I guess not. I don't know if I actually need it as a dependency or dev dependency or not. Oh, that was weird. 28.6. So I've got this. What do we have for extensions here? I've got a couple of Tamil ones. Which one is doing this? There's one that does this. Clear. Installed. Can I not search installed? That'd be kind of handy. Better Tamil is the one that gives us the syntax hiding, tells like about invalid, and then it does some. Don't think this is the thing that reorders creates. So that's what's doing that little check mark. Is it even better, Tamil? That's the thing that's like reformatting stuff. Yeah, so like being able to see what the latest is and whatnot is nice. So I like that one. That's pretty helpful. This one gives like, I don't, what do they call it? I don't use this focus mode, but it's like matching parentheses in other languages. I guess you kind of have to do similar here in Rust, but sort of the same idea, where depending on context and where you're clicking it like highlights things too. Help you see like the flow and how things are tied together and where functions and whatnot close. Prettier, Rust Analyzer, Tamil language support. So this is, I think, just language checking. So you're saying even better Tamil. Is that a different one other than this? I don't know which one's doing the reordering. I'm not gonna bother looking anymore. But if you're looking at getting any of these, I definitely recommend the one that tells you the version numbers. AWS Toolkit free AI code tools. I don't use AWS in a way that would be helpful for me, but you know, thanks for the note. Any like AWS that I'm doing tends to be with clients or through somebody that's handling DevOps for me. So most of what I end up doing is through like Kubernetes, Docker type things, for better or worse. Okay, at least specifically with AWS. Okay, so we don't. It looks like we're only coming in because of the tests. Let's clear out a couple of the testing because I don't actually care about this. Oh, that's interesting. This I think is a big test here. Yep. More test. Guess I don't need that. Really? Do I not? So just doing some weird highlighting here. Okay, so we got all the test stuff ripped out. Log. I did see something about, was it .log or just log? Thought I saw something with, oh, that's in the root. Log.workspace, that's what it was. Okay, so we want log. Grab that. And yeah, sure. I guess I don't really care if it's under dependencies or dev dependencies right now. I'm gonna come back and clean all of that up. We just want to get something running. Async executor. Is that something that is that an also dependency? I don't think I've heard of that. Oh yeah, all right. I would say I don't think I've heard of that one. Honestly, no idea what that's doing. Copy. Nice. Oh, what did I do? I meant to do this one. Oh, I guess they don't have a link to the logs. Interesting. Okay. Is this working out? We need that to stop reform or whatever. I don't care at this point. There we go. There we go. We're looking like we might have something that's going to run. So we should be able to say, this might trip us up a bit, run example, because it's not technically an example now. But if we do, I think we're just going to go into that folder and say cargo run. There's a way to run it from the root, but I'm not going to care about that much right now. So I think what's going to happen if for just doing straight at cargo run, I believe winit is gonna, or I believe we're gonna run it. It's gonna end up running through DirectX with a winit for the window. Unresolved import nanorand. Did we? I thought we did that one. Yeah, it's there. Maybe it's specifically because we're saying features. Again, I don't know that we're actually going to need that, so It's weird that it's not Rust Analyzer in VS Code appears to be okay with it, but not the case. Not the case when we run it. BiteMuck looks like one that we're gonna need to set as a dependency. This is actually way more involved than I was expecting it to be. Again, because I think when we first looked at it, it seemed very much like a copy and paste situation, but it's a little bit more complex than that. BiteMuck, Polster. And I think I was also expecting to be able to do the code actions. I thought that was a thing. Maybe I just don't have it working at the moment. Potentially possible. Yep. So what I'm going through is we added a sync executor. We should have log in there. And NanoRanch should be there. Sure. Wow. No. They used to. We're gonna use to. Oh, that's not gonna help me out. This is a workspace thing. Cargo run. I can never remember. Yeah, okay. So I can just do cargo run and then the actual like workspace name or the create name. But I'm still getting a dependency issues. Cannot compile due to 12 previous errors. We have BiteMuck. Oh, I wonder, is it? We're doing it. Okay, and Vlogger, there we go. Nope. I did not actually copy and paste it. And Vlogger. Yeah, so I had them in dev dependencies. Which makes sense that they weren't working because it needed them as actual oh. I now understand your message, Tab. I thought you meant that I was missing them and I hadn't put them in like they were missing in the cargo.toml, but you were saying switch them from dev dependencies to dependencies. Yeah, you were right. Definitely misunderstood what you're saying there. So let's go ahead and do a run. And I believe what I was saying before is I think this is going to open up with DirectX in a Winit window. Winit being like the Chrome, the thing that goes around it. And we will have to, oh my goodness. It's going fast. I don't know if it's just lots of frames. Yeah. But it's working. So next thing, let's get it working in the browser, and then we can start ripping stuff out. The examples, yeah, examples. So we needed to do what command? What commands? Was this the one? There was one that told us what exactly to run to get. to get it to run with so like this was what we were using to run the actual examples. Okay. Run examples on the web. Here we go. Okay. This is, I think, what we looked at last time. So we want to specifically, we're going to try to get it running on WebGPU right now. It might actually work with background eventually, but like the nice thing about signing it up in here is we have options, so we can always switch. We can like swap to or fall back to WebGL2 if need be. So what we can do is this. And that should run it in the browser, and it looks like we actually get. Oh. If I recall correctly, it is doing some of the WASM things for us. So like it's just gonna run. Like we're not doing a manual compilation. I think it's doing it for us. So I think we're gonna actually get this at the end of it. And if that's the case, then we can start like ripping stuff out. Oh. Well, still open it up in here, but oh my goodness. Oh my goodness. Interesting that that flag didn't work. What is my GPU? I got a 4090, new computer. A little bit of a treat to myself. A little bit of, this is a streaming computer, and I'm both streaming on it and wanting to do potential GPU compilation type stuff. And that'll give us options to do 4090. And that'll give us options to do lots of things and not limit our frames. I was running things off of a laptop before, so it's nice to have a little bit of horsepower behind the computer that I'm working off of. Yeah. And I do play some video games in my free time as well. Not gonna lie, it's pretty sweet with that too. I guess this is the first time though that I got a real nice GPU. I kind of I've done nice CPUs before. My previous laptop, like the previous computer that I was using, has an i9. I think it's an 8th gen. So like it was starting to show its age. But an i9, so like it had some compute. But the problem was that I was hitting thermal limits a lot. So like it could boost to pretty reasonable levels, especially for being 5 generations old now. But it would thermal throttle really quickly. And it was loud. So lots of nice reasons to actually go through and do the upgrade. But okay, so why isn't this running in a the browser? We can run it via we need to do cargo run WASM. That was a little bit that I missed. We were doing cargo run WASM. No such command. Fair. Okay. I'm pretty sure we're set up with Rust up because we did that last time. Maybe not. Okay. Let's try that again. No such command. Run WASM. Interesting that Oh, I bet you that's a dependency. Run WASM. Is it in the root? Cargo.toml? Run WASM? Yeah. Cargo run WASM. There we go. That should definitely be a dev dependencies. And now we should be able to do this. No such command. I don't have to do anything with bins or anything, do I? I do not remember. Okay, so still going through the cargo check. No such command run WASM. What are they doing to get it to install? I definitely don't remember doing a... Oh, that's kind of handy. I like that they do that. That's a nifty idea. Presumption here. You can always rip stuff out. TX fault, Vulcan metal. I mean, it's got it as a dependency, so maybe I just go whoop-de-doop. Go like that. Just call it a day. No such command. All right. Do I just install it? Why does it work? Why does it work for theirs but not in our situation? That is really weird. Run. Ah. So we've got some specific things for. We got WASM bindgen now. WASM bindgen features. We've got specific WASM dev dependencies. We've got WebSys with specific list of features. Let's go ahead and just do version equals features equal ease. Suspect we're going to want those. So this massive list. Oh. Sure. Holy. Alright, why are you not formatting it nicely? Yeah. Looks ridiculous. Is there anything else that we might be missing? There's a Naga dependency. We might actually need that. But we're still not getting a run WASM. So what are they doing in their setup where they're getting it? I would kind of like to have it with it, so I don't have to make sure that it's like installed as part of the toolchain. You know, search if you're. Oh, there it is. It's just hidden. Run WASM in this repository. That would do it. It set up an alias. Pretty sure I can just do that in the root. That's saying if you use cargo run WASM, what you should actually be doing is cargo run -- release -- package run WASM. Okay, let's try it in this one. Oh, yes. Now I don't know if I'm gonna need big web. Oh, okay. So I've got that set here. We could also have it as part of this. So we're actually gonna do, in here we're gonna do a dot cargo slash blast. What was it? Oh, it is a config.toml. You can also do these like cargo crate or cargo config type things in your like personal documents. Is it app data or whatever it is on Mac? Basically, like your home directory, there's a .cargo folder, which you can also have these configs, and that would be something that you would like if you want this to be applicable to any Rust project they're using, like on that computer. You could put it in the tilde or home directory .cargo folder, the config.toml there. But this is only going to apply specifically to this package or to this repository. So like if you went ahead and grabbed this, you would also now get this command. And that was, I'm pretty certain, the bit that we were missing. So we shouldn't actually need this anymore either because we're setting it. Okay. Run WASM was not found in workspace. We got some progress going. It is building things. And I think that number is bigger than it was before. So it might have actually picked. Well, we did actually add a bunch of dependencies. Run WASM was not found in workspace. Okay, so we have it in that specific package. Let's move it to the root. I don't know if it needs to be in dependencies or not, but sure. Okay, so I guess virtual manifest cannot specify dependencies. Lovely. So they have a workspace and then a workspace.package. Oh, that's what it is. I was doing a package. That makes sense. Okay, workspace.package. And then we can do a workspace.dependencies. I think I'm actually gonna move this up. I don't know if it actually matters or not, but it feels better as far as organization goes. Now we should get this. Cargo. Run WASM was not found. So it's in the workspace, but it's listed as a workspace dependency. So I think we need to now go into This is the root one. Where's the examples? Trunk. Yep. So now if we say run WASM cargo. Huh. I was just say we go into the other one. Members, run WASM. That feels weird. Why would it be listed as a member? So like those make sense. But we don't have a run WASM folder, do we? Oh, we do. Oh. Interesting. Interesting. Well, I guess I'm kind of glad that I set it up this way. So this should be a run WASM / cargo.toml. Did I put this in the right? Yep. Okay. I don't care about authors. And then we need a main.rs. There we go. Okay. Close. Start from the get-go again. So now we should be able to do this. Failed to load manifest workspace member run WASM. Failed to read. So it can't find. Because we have another folder level in here. We need to say this. Error indenting version. Wait, what file was that in? Failed to parse manifest. Additional run WASM cargo.toml. Oh, we must not have that in there. Yeah, we'll go like that. We do need the version. Okay, now that I remember how to do this, or know how to set this up, we're gonna do this. We're gonna do version.workspace, and we're gonna move the version to this. So now we have the version and the addition in the root cargo.toml, and we have the other two crates within our workspace using workspace.version and workspace.addition to reference those values. Okay. We are getting a thing running. We need to do one of package, example, or bin. So I guess in this case we have removed it from being an example. So I think we do -- package. Okay. Interesting. Could not compile NanoRAN due to previous error. I am going to go out on a limb and guess that that is a situation where we need a specific set of features from NanoRAN, and we are not specifying said features and is throwing an error because we don't have that feature installed. Or we don't have that feature added, subscribed. Nanorand. Did I spell that right? I wonder if I spelled that feature wrong. Nanorand features. Oh, that looks fine. It says it is using the one in the root. And that specifically says version 7.7, which is what? Ooh, that cough came out of nowhere. Ooh. Does this say that we're specifically missing that? So I'm thinking we just grab some of these. So this is WebSys. I don't know what some of these other ones do. I'm presuming we're gonna need the Naga stuff. So I'm gonna just go ahead and grab those. That feature list is really long. I don't need the alias here. Determine that that is not useful. Are you not happy? So, okay, so Naga is not coming from the workspace. Ah, here, workspace. True. Naga. Oh. I don't really want to put this to the root, but oh, oh yeah, we're not gonna put it at the root. We're gonna do this. I'm gonna do that. Version 12. Hopefully that is still going to compile for us fine here. Nanorand. Cannot find function backup entropy. Okay. This might be, we have something running and we were starting to the point where we were like ripping stuff out, but we were gonna run it in WASM. I think we took a peek and see where Nanorand is actually being used. See if we can just rip it out real quick. Because I don't know how much I care about running it. Just checking to make sure I don't have any okay. Checking work messages. Where is this showing up? Can we get it out of here? Because fingers crossed, this is the last thing that we do need to deal with. And rand range and y rand. So this is like setting up some particle stuff. Which is kind of at the root of like the thing that we're doing. I think it's gonna be hard to just rip this one piece out without like really doing some deep surgery. So I think we might end up having to get this thing to work. Let's go ahead and grab. I really don't like that, but because that's what we're gonna do. Naga. Okay, so that's the only reference to it. And then we're gonna say in here, we're gonna say this version, we're gonna say, what was it? Version.workspace equals true. Map. Expected a string in dependencies.naga. That's what they used, right? It's just workspace equals true. Still that. Are we going to be able to figure this out? That is the question. It's not found in the scope, which I'm assuming means that we are missing a feature. If we just do like all, does not have the, what if we just don't say any specific features? What are we gonna get? Still interesting. Is there any other caveats that they have in here? Default features is false. Yeah, let's just turn off all the default features. And specifically set this one to be y-rand. And maybe it's including something that we don't actually need, and that's throwing the error and not... Like, hopefully it's the thing that's failing is the thing that we don't care about. Oh. That's awkward. Okay, so we have localhost 8000. Hey, okay. Nice. We got that pulled over. Can we do... Can we rip out the stuff in here that we don't need and get it to compile again? We've got a bunch of, I mean, it makes it look like this is actually not used, but I think it is. So this specifically says target WASM 32. So if we look at, so not WASM 32, so we should be able to do Get rid of that. We got a spawner, texture format. So if it's not WASM 32, we do these things. Where does window come from? So the idea here is that I'm just going to, so if it is WASM 32, do that. If it's not, do this. The idea here is that I'm going to just remove all the things that are configured to not run in WASM 32. So we should be able to get it down to just the things that are needed to run specifically in WASM 32. So like this is WASM 32. That's a not. So we shouldn't need that. Let's say not target arch. So we can get rid of that. Oh, we can get rid of the M blogger. That's nice. And the surface can go away. Wait, configure not. Oh, no, we do need that. So we are starting to get errors here, which is not to be unexpected. Any not. Oh, maybe we do need that. So not WASM 32, not WASM 32. So specifically keyboard input is only going to be something that shows up in DX land. So the spawner isn't needed for that. This isn't needed. Got it. So here we get a spawner if it's just WASM 32. And not WASM 32. All right, configure any of not WASM 32 or target OS mscriptum. So mscriptin is like that ECMA script type thing. So if it is, that one's confusing. Like what case would that be then? I'm gonna ignore that one. Oh, here. Okay, so we got two options. We can either do this surface or this surface. So if I'm not sure which one it's going to be, so I'm going to leave both of them in there because we're basically doing a check between mscriptum or WASM. So not WASM 32, so I don't need adapter info. Not WASM 32, not WASM 32. We are getting an issue with the event loop. And the event loop, so if we have WASM 32, we are still doing an event loop, so we're gonna have to solve for that. Not. Okay. We got a couple here that like, that might just be because of the tests or something. But we do need to solve for, so spawner is supposedly not coming in, which I thought we have a spawner at the bottom here. That's just like an empty. So we're not doing the start at all. Where does the start get pulled in? So we're gonna get surfaces coming in from, it's like we should still be getting some of these, like the event loop. I'm expecting us to have that event loop come in. Okay, so this is not WASM 32. And this is it just flipping out a little bit because of that? I don't know that this still might work, but you can see the code like goes a little faded, I guess. I think it still would work. I think that's just like an IDE thing. We I think we're pretty close to it. Oh. What are we using that it's not? Are we just straight up not using like much of this framework? For examples, required limits. Init. Okay. So we do some stuff on top of framework. Now we're running the example. Interesting that it's not actually like throwing an error. So what's our framework here? Run. So we have an example trait with a bunch of like initializations and such, and then a setup. And there's no issues specifically with this setup. And we have a start. And all of our issues seem to be specifically with the start. I don't know that we really need this start. Let's go ahead and just snip the start and see what happens. Because we also have a run. And I think all of our code is happening in the run. Yeah. So closure. Once into JS, we're doing a start. And what does our start look like now? There's a setup. Start example. There we go. Okay, that's what I was expecting. Unused imports, sure. Expected function found built-in attribute start. So we are getting specifically an issue here with the start, but we're not actually hitting it. So the errors that we're seeing, I think, are Like it's due to event loop. And I don't think we actually have an event loop. So like, I think all that it's doing is setting up the Isn't it like this? Because there's only one. Okay. And I'm not sure. I don't think spawner is actually doing much here, if anything. And I think off-screen canvas setup. I don't know if that's actually used or not. So here, struct setup does not have a field name off. Yeah. Let's just do that. So I think we just about ripped everything out. Missing field offset. Okay. Guess we do need it. All right. We got a whole bunch of this ripped out. All the DirectX stuff. And I guess it's not. Some of this is like I'm wondering if. Hey Chris, good to see you. Some of this is. Yeah, okay. When we run the run WASM, we're getting. I don't know if it's the target changing or what, but we're actually getting like different. So Rust Analyzer in the IDE, I think, is going to give us different values than what we would see in the terminal. Just in time for success. Nice. I think we're actually probably pretty close to calling it a day too. Because work might be calling. I suppose we could deal with some of this real quick here. Struct setup does not have a field. I don't think I actually. Okay. Yeah, let's just hide that for right now. It's kind of interesting that like I've hit a bunch of these, or I've commented out parts of these, and then like I wouldn't expect this to actually cause an issue. But I must have destroyed some other like configuration switch somewhere else in the chain to where now it is. I think that's still probably have to configure Rust Analyzer for the target. That is probably that is probably a good call. Oh, server stopped. Oh, I thought I like did a format and I was like, wait, it's just all working now. I think you actually. I think that might actually be a good call. So we are doing WASM special target stuff. I do have it set in the config.toml. Just the Rust flags though. So I don't think there's actually anything here to tell Rust Analyzer that it needs to be doing WASM. Granted, as I say that, stopping and restarting it seems to be okay with it now. Okay. Guess I do need future. Despite it saying that I don't. Yeah, I think you might be right on that. Because like this, some of those seem confusing. So what we've basically done is we've ripped out an example in the WGPU repo, and we're sort of like trying to recreate it in as a separate thing, which is actually took a little bit longer than I was expecting, because this run WASM is a little bit of a separate beast. But I wanted to bring it along for the ride because it seems to be very helpful. I can do the cargo run WASM and have it run a specific thing, and it does all the WASM bind gen stuff plus sets up the server, which is lovely as far as a DX perspective. I think this is probably good as far as like modifications go, but what we were trying to do in the framework.rs is take their example or their setup that works for WASM and DirectX, etc., and just strip it up to like the pieces that we actually need. Because for this use case, and I think for any use case that I would put in this, I'm not going to care about that. And I want to be able to focus just on the WASM parts of it. And there's kind of more in here than I expected to see. I was thinking when we were first looking at stuff, I completely missed this import. And I was like, there's a lot of code here, but a lot of it is just setting up particle effects and stuff. And I'm like, okay, there's not too much here, and it seems like we don't need to do too much boilerplate. But it turns out that I was just hidden in this framework.rs. So I think what we're gonna do next time is the framework.rs is pretty much ripped up. We can clean that up. I mean, the success is we like ripped a couple pieces out and it's still working. So like, you know, the success and the change in what success looked like is very minimal, if at all. We might actually just keep this separate. So I think next time what we're going to do, we're going to look into Chris's suggestion on the target arch equals WASM 32 as far as Rust Analyzer is concerned in our IDE here. And hopefully that means that what we're seeing in the terminal over there matches up with what we're seeing here. That'll make things a little bit easier. And rip out a bit more of these pieces. And I think we're going to end up just leaving the rest for right now. And then what we're going to do is we're going to come back to this, and I don't know how much we're going to end up keeping it here. I suspect a lot of this we're going to end up ripping out. Because a lot of this is like setting up the particles and like movement stuff, which I'm pretty certain that our shader here is going to handle more of that, because the shaders that we have right now, I don't think are doing too much. This is more about movement and how they react relative to each other, I think. But we'll figure that out next time. That's where we're going to call it. We should be good on next week, Tuesday. I kind of forgot to actually this week that I had off on Monday, so Tuesday came up real quick when I didn't have Monday to sit down and like get into you know, computer mode, I guess, after the weekend. But it is what it is. So next time we'll dig into the shader more and see. I think it's going to be a bit of a combination of what does writing shader language code look like, taking this and like chopping it up a little bit and just how we tweak the variables and see how we can tweak the variables and see what it does. And get that wired up and replacing this, I believe it's the compute.wgsl that we'll have to end up changing. But this is a WGSL, and this is a shader language file. What is this written? Shader inputs. I don't know. What is... I don't see anything on here that says like, is everything on here WGSL? Oh, show. So this little thing here that you can't see. That says show GLSL help. So we do have a WGSL file, and shader toy, this one at least appears to be GLSL. So we might need to do a little conversion, and we might not be able to copy and paste that directly, but fragment shader on shader toy. I have no idea what that means, but I might ask you later, Chris, and I will update everybody next time. Compute shaders and fragment shaders are significantly different. Got it. So we'll figure that out next time. Yeah. I'm pretty sure I shouted out Chris last time. But feel free. I don't know if you can click their name. I don't know how to do shoutouts in YouTube, to be honest. But Chris, we'll just pull it up. Clearly, I did a shoutout last time because
over 5,000 lines of Leptos code. Leptos being.
And Chris just said that at this point, he has written over 5,000 lines of Leptos code. That's what that one said. Fragment shader is pixel colors. Compute shader is generic data processing. Okay. Compute shader is generic data processing. So that might be the one that we care about, which makes a lot more sense. There's a draw WGSL, which might be the fragment shader then. But next time, shaders. We'll dig into shaders a little bit more. And I think as far as topics go, and as far as like what we're trying to do with WGPU, if we can get this working and we can get some sort of shaders working and sort of understand how each flows into each, I think that's probably going to be about as deep as we're going to dive on this rabbit hole for right now. And that's going to be able to serve us a foundation for when we look and start going into the low-level parts of Tari and see how all these things sort of integrate together, and how we could use something like what WGPU is doing and handling, and how that could potentially be used in the world of Tori. You can see the @ fragment for the fragment shader. Oh yeah. Right there. Yep. Okay. Computer shader, just like, yeah. So, and that coming back around to the GPU conversation we had before. I'm very fuzzy on this. Chris definitely knows more about this than I do. The shaders are something that GPUs are very good at computing. Which is so WGPU and WebGPU. The intention here is that rather than going to a web page and having your CPU doing all the drawing and the layout, like this kind of stuff, this is 2D, not as big of a deal. But once you start getting into like deeper 3D stuff, that's going to be a lot to ask for your CPU to handle. So if we can throw the compute and the shaders on the GPU instead, the GPU is meant to handle that. So that shader code is something that GPU compute is very good at handling. And then there's the whole thing like CUDA cores and I don't remember what the AMD one is, but I get even fuzzier on what it is. But it, like, each of those cores are partly marketing, partly like this thing is specifically built with the expectation to process or compute a certain type of code. So shaders in the GPU, you know, the specific build rather than like generic CPU processing. All right, I gotta get going though. I gotta actually get some work done today. Thanks for stopping by, everybody. Next week we should be good to go on Tuesday. We'll continue a little bit with the shaders and anything that I've gotten wrong. Hopefully we get it figured out by next week, or we will figure it out next week. And hopefully we can get things moving around on the screen. Make this look fun. All right. See you next time. Bye.